Inertia, Part 2. Why the current definition of inertia is wrong. What should be the correct definition of inertia? In this video it will show that in Inertia Part 1, which tells us the current definition of inertia, that the definition of inertia going back from Isaac Newton is actually wrong. In this Inertia Part 2, I will forward what is the correct definition of inertia. The current definition of inertia, called the Law of Inertia, came from Newton's first law of motion, which is stated as: every body persists in its state of rest or uniform motion in a straight line, unless it is compelled to change that state by forces impressed upon it. What is wrong with the current definition of inertia? Notice that the current definition of inertia can be divided into two parts. First part, every body persists in its state of rest, unless it is compelled to change that state by forces impressed upon it. Second part, every body persists in its state of uniform motion in a straight line, unless it is compelled to change that state by forces impressed upon it. Notice that the first part is that of a body in a state of rest and the second part is that of a body in the state of uniform motion. Also, that the two parts of the definition of inertia mirrors that of Newton's falling apple and the orbiting moon. In the first part of the current definition of inertia, inertia is related to the falling apple. Gravity pulls a body downward towards the center of the earth, resisting the movement of the body from going sideways. Likewise, a body on the surface of the earth being pulled down by gravity, that is, towards the center of the earth, is being prevented by gravity from being moved. In the second part of the current definition of inertia, the state of uniform motion is related to the orbiting moon. The term uniform motion was a throwback to Galileo's description of inertia, which gives an example of a body rolling in a frictionless surface, but in this sense, the only possible way for the body to move in a uniform motion is for the body to move on the surface of the earth at an equal distance from the radius of the earth, which is not usually possible. There are other examples stated that the uniform motion can be achieved. One is by firing a cannonball at a certain angle so that the ball can achieve an escape velocity and orbit the earth, and another is a satellite carried by a rocket in its orbit. But as is the case, in both examples, the cannonball and the satellite will eventually fall to the ground. There is only one satellite of the Earth that is able to travel at a uniform motion around the Earth, and that is the Moon that is orbiting the Earth. The first part of the current definition of inertia is that of a body with no force applied to it, but it will resist when moved. The second part is that of a body that has already a force that was initially applied to it, or even a force continuously applied to it, but it will change its state when another force is applied to it. This means that the first part and the second part of the definition of inertia are actually contradictory, which made no sense when analyzed, one description for both a body in stationary and in motion. In a sense, Newton just accepted the second part to be true as it was coming down from Galileo to Descartes, practically the same with us from accepting Newton's definition of inertia. A deeper argument on why the second part of the definition of inertia is wrong is that if that body is a non-gravitational producing body, such as a satellite, while it is being pushed by Earth's gravity to orbit around Earth, Earth's gravity will eventually pull it down. If that body is a gravitational producing body, such as the Moon, both of their gravitational field will interact and will ensure that the Moon will orbit the Earth indefinitely. So, what we are left of to describe inertia is that of a phenomenon of why a body resists its movement. Therefore, the only correct definition to describe inertia is that a body in the presence of gravity resists its movement. We can observe that the aforementioned definition is in reference to a body. Another correct definition of inertia is that of a body in reference to gravity. Gravity resists the movement of a body. Thus, inertia is just our definition to describe the effect of gravity on a body, especially on its surface. Inertia is caused by gravity. Furthermore, falling and inertia are practically the same. Gravity makes the falling body fall straight to the ground, that is, gravity prevents the body from falling sideways, just as gravity prevents a body from being moved, which we called as inertia. Falling and inertia are caused by gravity. The popular demonstration of inertia uses the trick of pulling the tablecloth with tablewares on top. The trick to this demonstration is to use a tablecloth with no folds on the seams to prevent snagging the tablewares and to pull it fast. This demonstration of inertia uses a stool and a glass with water on top of the paper. What the demonstration of inertia showed is that it actually does not matter whether the glass is resting on top of the paper or is dropped on top of the paper. The tendency of the glass to stay in place, as the paper under it is being pulled, which is called inertia, is the same tendency of the glass to fall straight down, and both are caused by gravity. What is the significance in the correction of the definition of inertia? From Galileo to Descartes to Newton that came down to Einstein, the understanding of inertia was wrong. That is, if we consider that Einstein based his relativity on Galileo's purported relativity or even Newton's definition of inertia, then Einstein based his relativity on the wrong understanding of inertia. More than this, it will be shown that Einstein's relativity is wrong or that there is no such thing as relativity. That is, there is actually no inertia in Einstein's relativity, theory of special relativity, and theory of general relativity. I challenge all the brilliant people, science and physics teachers and professors, scientists, and physicists to analyze the current definition of inertia and see if it really makes sense or it is wrong. A definitive understanding of inertia is one of the steps towards showing that Einstein's relativity is actually wrong.
Please give proper credit to the author for discussion of his ideas and theories. Thank you.